Stay tuned for lesson 107. We're going to talk about graphing and slopes. It's going to be so exciting. Woohoo!
The answers to the warm-up are here. We've got, this is going to be positive. Two negatives make a positive when you multiply. And so 2.5 times 4 is the same as 2.5 times 4, which is 10. Or you could think of 25 times 4 as 100 with one decimal point behind the decimal, which makes it 10. Okay, this one, I did 25 times 25, and I get 625 with two digits behind the decimal point because we have two of these. So we get 6.25. And then we do 6 plus 6, which is 12. Okay? Letter C, if we added this to that, we would have 2x equals 6, so x equals 3. Or you can think of it this way, 6 minus 1.5 is 4.5. Okay, when I converted, I did negative 50 divided by 5 and got negative 10. Negative 10 times 9 is negative 90. Negative 90 plus 32 is going to give us negative 58 degrees Fahrenheit. Okay, 75% of 60 is the same as 3/4 of 60. Well, 1/4 of 60 is 15, so 3 of those is 45. Okay, and then this says 75% more than 60, so it's 45 more than 60, so we get $105. All right, let's jump into the lesson. It's exciting stuff. We're talking about graphs, and a few weeks back I told you that every equation that you see has something that can be graphed on a coordinate plane, and we're going to start by doing linear equations this year, lines. Okay, now let's look at this. This is a graph of the number of feet that equal a given number of yards. So if you have 1 yard, that's 3 feet. 2 yards is 6 feet, and so on. So we've got yards and feet. Now this is the inverse, meaning we have feet for the x-axis and yards for the y-axis. And so that means if you have, see out here, 3 feet, you have 1 yard. And if we go out 6, you have 2 yards. Okay, so notice this line is steep and this line is not as steep. And what we call that, the steepness of a graph, is called the slope. Okay, that's what this whole lesson is about. So the steepness is the slope. Okay, and what I always kind of think of is we write from left to right in the languages, right? We read from left to right. We also read graphs from left to right. Meaning, if I were in a car, I always kind of draw my car up here. If I were in a car, yeah, I'm a terrible driver. Or a terrible drawer of, I'm a terrible driver too, but yeah. So I'm in a car, right? And if I'm driving this way, am I going uphill or am I going downhill? So our cars always drive this way across the graph. They drive along the x-axis from negatives to positives. And are you going uphill or are you going downhill? And that helps you determine whether you have a positive slope, negative slope, a zero slope, or cannot be determined. So let's look at example 1. We're going to look at all these pictures and determine whether or not each line is positive, negative, zero, or cannot be determined. Okay, so here's our little car, right? And it is driving. And if it hits this line, is it going uphill or is it going downhill? Yes, it's going uphill. So we say that is a positive slope. Okay, write that down. Positive slope. Notice they gave the equation of the line here. Remember, every equation that has a y, a single y and a single x is always going to represent a picture of a line on a graph. Okay, now let's look at the car driving across this. Is it going uphill or downhill? Well, it's neither. It's a nice flat, I mean, if you're on a bike ride, that's kind of easy, right? Just nice and flat. And so if it's flat, it's not neither going up nor down. It is going to be a 0 slope. So a slope of 0 is just flat ground, okay? Now let's look at the next picture. Okay. We've got our car driving, right? Here's my car. What? I bet you guys are drawing much better cars. And it's driving across the page this way. Is it going uphill or downhill? All right, obviously downhill. So this is a, you can write it here, negative slope. All right, now the one that probably stumps people the most is this one. Whoa, let's drive that in a car. Yeah, impossible, right? Drive straight up and down. Gravity will not allow that. And so what we call that is cannot be determined. So just think, if you hit a vertical line, that's going to be the most impossible to drive in a car. So that's how I remember that this slope cannot be determined. There is no left-right component to the graph line, so we can determine it, and you might hear it taught a different way next year, but that's how I think of it, is if I'm in a car or a bike, how's it going to go? And this would be brutal, okay? All right, so every slope has a number, okay? A slope is either a fraction or a whole number, okay? So this has a slope of, I'll just tell you, it's going to be, looks like negative 1/2, okay? So every slope, and I'm able to figure out what the slope of this is just by looking at it, okay? And the way we determine it is what we say rise over run. Rise means up or down. I want you to write that. Up and down. Or we call it it's our y component. Our y tells us how high, right? So when we go up or down, we're traveling the y-axis. And the run means left or right, from left to right. And that's your x component, because it runs along that x-axis. So rise over run, you're going to hear that for the rest of your math career, okay? The slope of a line is the ratio of its rise to its run, rise over run. So like I said, we can look at graphs and determine what the slope is. Let's look at these two. Okay, I have these big dots here so we can really tell. You can start at one dot. So what you do is you find a spot where it perfectly crosses to a coordinate. I wouldn't pick right here, as you notice on your paper, that this line does not actually go right through the grid at an intersection, and neither does it up here. So where the solid dots are where they perfectly intersect at a whole number coordinate, okay? So here we go. To find the rise or run, you pick one, pick a point, and you figure out, okay, how high does it travel to get to the next point? See how it goes up and over, and then it's going to go up and over. So you kind of like staircase, up and over, up and over. Okay, so look closely. How high was the rise? It went up 1, 2, 3, and then cut over 2. So its slope equals 3 over 2. And we can leave it as an improper fraction. So the rise was up 3 and over 2. Now the book, some people do it this way. They, I don't know why. The book drew it down here, but to me that makes you do the run first and then the rise. So I always go up and over, up and over. However, so that's when and that was a positive slope. I wrote a positive just to give you the visual. We don't need to write positive. But as you remember, when I drive my car, it's going uphill. Unlike this next one, the car is going downhill, isn't it? So this has a negative slope. So before I do anything, I go, all right, I already know it's going to be negative. And I just want to figure out my rise and my run. So I'm going to pick, okay, so got 2 points here. We could have used these two, it doesn't really matter. Or we could have picked 3, skipped 1, and I'll show you what happens when we do that. So let's look at these two, and I see that my rise is 1 and my run is 2. So it's 1/2, but we already determined it was negative because it's going downhill. So it went up 1 over 2. So sometimes it goes up and over to the left, sometimes it goes up and over to the right. If it goes up and over to the right, it's positive. If it goes up and over to the left, it's negative, right? This went up and over to the right, so it was a positive. This went up and over to the left, it was negative. But again, if you just think about riding your bike, which one are you going uphill, which one are you going downhill? Okay, what if we didn't see this point right here and we looked at this one and this one? And we're thinking of rise over run. So what if you go, oh, well, it went up 2 and it went over 1, 2, 3, 4. So the rise would be negative, or the slope would bend negative 2/4. But once we reduce it, you'll get back to what it was if you didn't miss that middle point. Okay? In fact, all of these, if I drew from here up and over, my fraction will reduce to negative 1/2. In this case, it's 1, 2, 3, 4, 5 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So negative 5/10 reduces to negative 1/2. So it's going to work no matter what. You just might have to reduce if you didn't pick 2 points that are right close to each other. Okay, example 2. Find the slope of this line below. Okay. So what I like to do first is survey the picture and determine right away, is it positive or negative? Okay, and I see that if I were riding my bike, I'm going uphill, so it's a positive slope. And I'm going to look where I can find perfect points. So you could use this, looks like it intersects perfectly. This one, this one, this one, and this one. Okay. So I showed the solid dark dots there. So it doesn't really matter, just pick between 2. Pick between, like I said, you could do big, and then you could go up and over all the way over here, but you're going to end up reducing that fraction. So here's my rise is 2, and my run is 3. So the slope is 2/3. Okay. That is it. It's actually very fun as long as you remember rise over run and don't switch these two, which for a while until this becomes natural for you, you might get mixed up. So really try and remember rise over run, rise over run. Rise is your y change and your run is your x change. Okay, so go ahead and do the practice and then you can come back and check your work if you'd like, or look in the solution manual. Okay, so letter A says find the slope of the yards to feet and feet to yards graph at the beginning of this lesson. So I'm going to go back to my picture, or you can look in your book, and we're going to look at the slope of these. Okay, again, rise over run. So it looks like it goes up 3 over 1 for the first one. So yards to feet, slope equals, remember, up 3 over 1, so it's 3 over 1, but we can simplify that to the slope is 3. So if it's 3 over 1, we just say 3. Okay, and then the feet to yards, let's look at that one. Okay, looks like it's hard to see. So what if I took a point right here, and then I took that point? It looks like it goes up 1 and over 3. Okay, they're inverses of each other. Isn't that interesting? And that's also positive because you're going up, it's going uphill. Okay, so we're going to find the slopes of the graphs A and C in example 1. So here is A, and like we said, it was a positive slope, and let's figure out what it is. It looks like, if you noticed here, it goes through these 2 points, right? Your eyeball may not have seen that it also goes through this one. So let's say we had it at 0, -2, and 2, 0, and that means it went up 2 over 2, right? So up 2 over 2, which simplifies to 1. And so that's the same as up 1 over 1. So anytime it goes up perfectly on the grid, see these little stairs? That's a slope of 1, positive 1. Okay, so A, the slope was 1. And C is hiding from me right here, upside down, sorry about that. And we've got this picture, and I right away see we're going downhill, so we're going to have a negative in front of our slope. And I see this perfect point here, and it looks like there's one here. And I kind of check to see if they're equal distance. That means I can see it. I'm getting old, so sometimes it's harder for me to see where they are crossing nicely. Okay, so again, it's up 1 over 2. So you do rise over run. Okay, so you start at one point, go up, and then turn toward your line, and there you go. So it's 1/2. But remember, we said it was negative because it's going downhill. So the slope of that is -1/2. Okay, letter C, find the slope of each graph line below. Okay, so it looks like I see a nice point here, nice point here, nice point here, and those look pretty evenly spaced. Okay, so how about I start here, I go, oh, and I see it's going uphill, so it's a positive slope, and it goes up 1 over 3. So the slope is 1/3. Okay, this one, downhill, and let's see where we can find nice points of intersection. Looks like right here. And right here. Okay, and those all look about equal distance apart. So we go up 2 over 3. And it's negative because it's downhill. So -2/3 is our slope. Okay. It's actually quite fun, I think. And then I guess we've got more of those to do. The slope of this, again, so we said rise over run, right? However, remember if we were riding our bike or a car early on, we said you either have a positive, negative slope, a positive slope, a negative slope, a slope of 0, or cannot be determined. And we had said that if it's just flat, you have no slope. It's flat, right? So let's say we tried to do rise over run. Let's say we went from here to here. Okay, what's the rise? Well, it didn't have any rise, so the rise is 0. And then we go over 1, right? So it actually does reduce to 0 anyway. So flat lines are 0, and you could see why. There is no rise, okay? It doesn't go up or down. With the vertical lines, it only goes up or down, and it has no run. So it would have been like something over 0, which is illegal. We can never divide by 0. And we will go into that a little bit more next year, okay? Or a lot more next year. Okay, so this one, let's see. Yes, you're probably thinking, oh, it's a negative slope. Okay, good. And I see that it crosses there nicely. Looks like it crosses there, there, there. Yep, I see the pattern. Okay, so it's negative, and if I start at a point, I'm going up 2 over 1, up 2 over 1. So the slope is 2 over 1, which is 2. And we said it was downhill, so it's negative 2 over 1, and that simplifies to -2. Right, letter D is an interesting way to ask. I've never seen a question like this, but I'll show you what they mean. For each unit of horizontal change, so for every time it moves to the right once, how much does it change vertically? Okay, so let me give you the first picture. So they're saying here, for every unit it goes over 1. So let's between here and here, there's a horizontal change of 1 between these two lines, right? How high does it go? and it goes up a third. Okay, so that's about a third of the way up. So this line crosses at a third. If you don't quite understand where I got that, it's okay. Don't stress. They're pretty much, it's the same way of asking what the slope is. Okay, this one, if I go from vertical, so between this, if I go over 1 unit, between 1 unit, how much does the horizontal or the vertical change? And it goes down, right, from here, and it goes down about 2/3 of the way down. Okay, so again, negative 2/3. So they're just getting you another idea of how to think of slope. Okay, this one, between one horizontal unit, what was the vertical change? The vertical change was 0, right? And this one, if between 1 unit, it goes down 2, right? So we're going to say negative 2. In fact,